Oh, from the second age of reason. I don't know if they can hear me from this distance. I'm going to get a little closer to the camera. On this beautiful winter day, when it feels almost like summer, I'm going to talk to you about the prejudice of physics. We live on this planet with beautiful climates, with air, with nice temperatures, with other living things, and plenty of water. And we have come to assume, take it for granted, that this is normal. Everything else in the universe must be abnormal. But in reality, this is a paradise in the overall universe of things. So I thought I would just describe a few things that might not be considered a paradise, to give you an idea about how prejudiced we are in terms of our perceptions and our knowledge of physics and the very sorts of planetary things and stellar things that are out in space. For example, let's think about the sun. The sun, people look at it and they think, oh, it's a star, it's burning. They think in terms of fire, primitive fire. Well, I'll tell you a truth. There's nothing burning on the sun. The sun doesn't burn at all. To burn, you have to have oxygen, and something that makes the oxygen combine with other things, and that's fire. But the sun has really no oxygen. It is hot. I'm not going to say it's not hot. It's very hot. But what the surface is like is something that's beyond any of us to imagine or perceive. Because there's something on the order of like 5,700 degrees Kelvin, which is like 11 or 12,000 Fahrenheit. And even the dark spots, the sunspots, which are the cold spots, are 8,000 degrees. And you would think, does the sun have a surface, or is it a ball of gas? Well, the so-called ball of gas has 28 Gs, 28 times the gravity of Earth. So, since 7 is probably enough to kill you, you could not exist for long on the surface of the sun, even if the temperature was no object. They have shown like comets crashing into the sun, and it made a splash. So you know the sun is made out of something that can be displaced, something that can be moved about on the surface. And they've also shown tornadoes on the sun. So you know there's thermodynamic forces that cause things to move and swirl about. But other than that, it's beyond perception. You can look at it, you can see it. Astronomers have filmed it in great detail. The surface, with the right kind of telescope and lens, looks granular. Like it's, I don't know, like corn in a cob up close. So, but you have to realize that corn in the cob is at 10,000 degrees, and that you can see the surface kind of bubbling and frothing and doing stuff. And you wonder, is that solid, liquid, or gas? Or is it like in a fluorescent light bulb? Is it plasma? Glowing neon? But you know, as you get deeper and deeper into the sun, it's got to get denser and thicker. So that makes it even more perplexing. Is most of the heat inside the sun? Could the sun possibly become liquid or solid deep down? Could it be colder on the inside and just some kind of reaction in the outer layers be hot? And some have said the sun will last X billion years. Well, that's assuming kind of like it's consuming something to do what it's doing, so I'm not sure how that process irons out. So at this just thought I would bring up the sun, the star that's closest to us. It's not just a ball of gas, and it's not fire. It's something else. But it's the thing that most influences our temperatures. People have talked about, global warming or climate change. But you have two examples of planets with carbon dioxide atmospheres, and they're quite different. So you have Venus, which is closer. It has a carbon dioxide atmosphere, and they use that typically as an example of greenhouse gas effect, getting the surface of the planet to 900 Fahrenheit or 500 centigrades. And then you look at Mars. Mars, they don't want to talk about it as much in terms of its 100% carbon dioxide atmosphere, and it's still 100 below zero. What's the difference? The biggest difference is probably the distance from the sun, which is the amount of heat that it gets, the way energy radiates outwards from a central point. That probably has more to do with it. So fluctuations in the sun's output would have a greater influence than minor changes in the composition of an atmosphere. So that's probably the biggest influencer, and perhaps the sun is putting out a little more energy for some reason or other, and that's a bigger concern. Or you could say, well, what if the Earth is supposed to get warmer? At some point, maybe the Earth could get colder, and that could have an even more detrimental. That could even have a more detrimental effect. So I thought I would just bring that up. But a lot of our perceptions are tinged by our experience in physics, the physical world around us, the temperature, the pressure, the climate, the composition of things. We have no idea what it's really like up there. I mean, the moon and Mars are probably the most friendly object in our solar system as far as life goes, and they are still enough to kill you if you go on the surface without protective clothing. So I just thought I would mention that, and I've rambled on enough about the sun.